Hi. How you all doing? Right, so let's keep going. Hi. How's everybody doing? The lights here are like super blinding this year. I don't know why. Like I can't see any of you, or maybe it's just, I don't know. I can't see any of you. So I'm assuming that you're all smiling and happy and PyCon is treating you well. Sweet. So my name is Idan, and if you don't know me, I'm a designer developer hybrid, and like Dana said last year, respect. Like Dana said last year, we looked at GitHub as this fascinating community. It's like the record of our development. You know, for a long time, we've all been developing open source stuff all over the place in like a lot of different, like there was SourceForge and there was like private CVS repositories, but they were all sort of these islands, these disjoint like locations. And so we wanted to see how we could pull together all this information that we have in one place on GitHub to see if we can look in the mirror a little bit as developers. So the first part was really about, like the dirty work of like actually acquiring the data and like setting it up so that we can start working with it. And this part, hopefully, I'll be able to show a little bit of the first products that we're starting to see from this. I'll warn everybody that it's not finished. Like we just started working with this and we just started getting some visualizations up. And actually, as this week goes by, I hope to throw more and more up. But we'll be giving you like a sneak preview of like what the website looks like and the kinds of questions that we thought that we could answer. So just like briefly about me, I do data visualization in the context of a consultancy called Umbrella, and we're working on a product for visualizing mobile like application activities, kind of like Mixpanel for geo. So if that's something that sounds interesting to you, please talk to me because I really want to like pick your brains about what you need. And I guess like the real claim to fame that I have is that I'm one of Django's core designers. Django is awesome as a project in that they respect that design is a talent that you need to have as part of your like core team. Brian Veloso is another, and he's sitting here in the front row, and he works for GitHub, so I hope he's totally not going to hate on our talk soon. So Dana covered data to information. Information to meaning is like it's a harder leap to talk about because it's less like practical tools. It's more like general strategies that you need to sort of apply with some amount of discretion. And that's generally true of design. Like you're working on designing anything, even at the code stage, it's still all about constraints. Like constraint, we don't have a lot of time. Constraint, we don't have a lot of money. Constraint, we don't have like, private servers running somewhere. We have to like, buy the computing horsepower we need by the hour. So even before you have visuals, even before you have your first line of code, you're already thinking about constraints. And the problem with visualization is that it's like very much like a chicken and egg scenario where you don't know what you need until you have it, and like you need that in order to figure out what to get. And so you don't really know where, like, how to get started. And that's why Ben Fry really said this like, really important quote about how information visualization is like the natural field for hybrids. That you need to have all these talents in one team in order to get it done, because all of your like decisions affect your earlier decisions, and you go back and double over like the steps you've already taken. It's one of the only fields where you need to know sort of the output considerations before you even figure out like what input you want to get. It's strange that way. Okay, so like step 5 in like this like 7-stage like acquire, parse, filter, mine, represent, right? How are we going to choose like a good visual representation for the information that we have? The thing that we're producing in the end is it's a story, right? And we have like a lot of practice with stories. We've been hearing stories and telling stories to one another since we're kids. And humans, like as a people, we've been telling stories for a long time in a lot of different mediums, right? Maybe longer than we've even had words. And sometimes we don't use we don't use the written word to tell stories. We use other mediums for telling stories, dramatic mediums, and they can convey things beyond just the text. They can convey emotion. Sometimes we don't even use words to tell stories in different ways. It's not just drawing on a page. Music can convey a story. And sometimes the stories are entirely devoid of information. Sometimes they contain just emotional content. So there's a lot of different kinds of stories. But what they all have in common, you know, all these different stories, is that they convey some meaning, right? At the end of the story, you walk away with some understanding about what happened in the story. What does it mean, and what does it mean for you and your life? And meaning requires context, right? You can't just supply meaning in a vacuum. For all these mediums, people have considered what information their story can carry, right? If it's like a piece of music, like what information can we put in this? There's the lyrics, there's the tone. Is it upbeat? Is it downbeat? Is it happy, sad? Like what chords are we going to use? There's a lot of these different ways that musicians use to encode information into their stories. Visualization is a lot like that. Except that it's still in its infancy. Like, when we look at data visualization, people have been writing stories, like using the written word to convey stories for like thousands of years, and pictures just as long, music almost as long. But data is a pretty new thing. Like, we don't have like data as a storytelling device up until fairly recently. So we're still just taking like these baby steps. Everything that you see nowadays is us figuring out what the constraints of the medium is. If you think about how music has evolved over the years that there's been music, there's been like an explosion in like the richness and the kind of music that we're able to produce, both technologically and in terms of like, you know, how we figure out that we can join, you know, this limited scale of notes together in like an infinity of combinations to produce meaning. Yeah, they've had a lot of time to like push their craft forward and really haven't. So the context that we need most is medium and audience, right? It seems obvious, maybe, but it's actually an important distinction. It's something that you need to think about at the very beginning of your product and have really firmly in your head when you're going from some structured information to something with meaning. Extracting meaning from data is already really hard, right? If you're going to be taking people's attention and trying to like use it to stuff some meaning into their heads, then like you're fighting an uphill battle. They're already struggling to like make sense of, you know, okay, you're displaying all this stuff and what does it mean, and do I need to look over there for the key, and like what does this chart relate to? And you're usually fighting like a paucity of attention. And this is something that journalism is grappling with really hard right now, because they're writing for a general audience. Unlike us, like in this project, we knew that we were going to build something about geeks for the web, for an audience of other geeks. And that made our job relatively simpler, because we knew that we could focus on a specific audience and come with like a couple of things that we could assume about them. Like we could assume that everybody that would see our stuff would know about GitHub, right? And at least they knew something about code and development. Maybe they wouldn't be developers, they might be like designers, they might be like mathematicians who've written something in like MATLAB once. But they've heard about this GitHub thing and it sounds interesting and they like to check out, like, you know, what it's all about. And they had to have like some element of curiosity. Like, we aren't going to pitch this to like a general population of people that don't care about GitHub. So yeah, so this makes our job significantly easier. And I can't overstate this enough. Telling a successful story is a million decisions about what to put in and just as much what to leave out. If you don't know who you're speaking to, then you won't have a basis for making those decisions. And it's really easy to fall into what I call the eye candy trap. Especially if you don't have like a clear idea, because it's hard to spot the difference between like eye candy and like bona fide stories, right? Even like meaningless arrangements of data can mesmerize. They can be beautiful. It's still noise, But it's beautiful noise, and people will look at it and be like, oh, that's a beautiful visualization. But a visualization of what? Like, what meaning does it convey? It's hard to stay on track, even though it's very easy to fool people into thinking that your visualization has some deep meaning. But if they don't come away with that meaning, then you haven't really done anything. So okay, so we have this pile of data that we've acquired using a bunch of tools. I know Dana said that I'd cover like the tools and whatever. I think we'll come back to that at the end of the talk. Maybe we'll have like more questions, because I did, I think, a little bit more of some of the tooling. So we'll come back to that at the end. So we've got this pile of data. We've identified our audience, and we've picked a medium. But like, let's start digging into that. Let's go a little bit deeper. Right? How are we actually going to render our displays? A lot of the decisions that we make up front, like I said, you have to like double back and take this information from the end of the process and feed it in the beginning. There's a lot of tools out there for doing data visualization now. Like I said, it's an exploding field. And probably the most famous one, the one that was written by Ben Fry, the guy that we keep referencing in this talk because he's such like a luminary in this field, is processing. I think processing is really cool. It's a lot like Logo. Who here like programmed in Logo back when they were like, you know, yeah, awesome. Logo was a lot of fun, but Logo was like a very simple descriptive language for, say, like, you know, you have your turtle, it has ink, and you like tell it to go forward this much and then turn right 90 degrees and then go forward this much. And if, you know, you do that enough, then eventually you can draw like, you know, something and show it to other people and be like, look at what my computer drew. Processing is a lot like that. At the end of the day, processing provides you with a canvas and a bunch of methods for drawing on that canvas. And some related tools for taking data and then, like, you know, you're going to loop over that data and issue instructions to draw on your canvas. But it's not exactly, it's not meant for the web. And the web is probably a more interesting place for us to be presenting our information. First, because everybody has the web installed. Like, you know, with processing, your output is going to be like a Java applet. And if you care about your computer, you've probably disabled Java by now. So yeah, and this is kind of a lie because there is processing JS written by John Reisig of jQuery fame. And they actually use that at Khan Academy to teach programming, which I think is really interesting. Like, we talk a lot about like Python in education. From my experience, like very limited experience teaching like programming to people of the 10 to 13-year-old set, that demographic likes visual results fast. And processing is fantastic for that because you teach them a couple of commands and bam, they've got their computer drawing something, and all of a sudden I reconnect to that feeling that I had when, like, you know, entering commands to Logo. So processing is really cool that way, but it doesn't know anything about hyperlinks. It doesn't actually like render something that's interactable in the browser unless you do a lot of work. And processing JS is only like, you know, it's a band-aid on that problem. It's not a real solution. And so the hot shit right now in the world of like visualization is D3. Who here has heard of D3? Who here has used D3? Who here really understands D3? Yeah, that's my point. D3 is a really mind-bending library. It takes a lot of time for like the penny to drop about what it can do, and once it does, your head is just like, oh my god, the awesome. But I think it's the first true visualization toolkit that deserves the name. Because visualization is not really about drawing. Like I said, it's about meaning. And it's not about charting or drawing charts. It's about mapping your data onto meaningful visuals, right? And if you're doing it for the web, what you're really doing is you're taking data and you're mapping it onto the DOM, right? Because that's how visuals happen in your web browser. You're like affecting the tree. What D3 supplies you with is actually a bunch of primitives. In the same way that, like, you know, everybody here has worked with Amazon Web Services, actually like putting together like a complete like working, functional, tested, battle like hardened web stack on Amazon is actually a lot of work. You have, like, they supply you with these wonderful primitives that you can build anything out of. But then actually building like a functional thing out of them is like a lot of stitching together of different pieces, and you know, it's like all the control, all the headache. And D3 is kind of like that. It supplies you with all of these primitives. Most of the time when you're mapping information onto something else, what you're really looking for, you're reaching for a scale of some kind, right? This input should be this color. That output should like map onto some dimension or some other visual property. And you don't want to write all this stuff, like writing something that will generate like a logarithmic scale or quantile scales when you want to start doing like histograms or ordinals or times. And it's like a lot of dirty work, like dealing with different time formats and what happens if like my scale is not like a round scale. You don't want to show a scale that goes between like 0.873 and like 9.2. You want to go from like 0 to 10, right? And you don't want to write a piece of logic to take an input with that natural range and expand the edges of your scale to something nice and round. But D3 actually supplies that to you. You can ask it for like a linear scale. And you give it like a domain and a range. But if you added .nice to the end of this, it would actually do the dirty work of like nicifying your scale, which is convenient. But yeah, at the end of the day, you feed it some data, you run it through some scales, and you get values that are meaningful. Or meaningfully visual or easy to apply to visuals. And this works for numbers, it works for dates, it works for colors, which is really important, and D3 knows about different color scales, so you can do color math in like LAB and not just, you know, RGB and stuff like that. And it helps you with dynamic interpolation of things, so dimensions, positions, colors, all these things you can tell D3 to animate them in addition to just setting them. And this is really important because a good visualization encodes like a lot of dimensions of information. When you want to like load a visual element up with more meaning, you have like a couple of different things you can load onto it, right? You can like change the color and the position and whatever. And when you look at most charts, like simple charts, these are technically visualizations. They're just like sort of the more basic, the most basic visualizations. They're not encoding that much data. Like here I have like, you know, two things. I'm using color just to make it easy to separate the two, but I could have this be in black and white. I guess technically, like, you know, I'd have to label every one of the pairs of colors with like their labels like apples and bananas, but I wouldn't actually need color. If I wanted to do this in just black and white, I could. It would just be like problematic. But if you're looking for like a real visualization, something that encodes like a lot of information, D3 makes it easy for you to like apply all of that different kind of information. This is something that was done by Mike Bostock, the guy who invented D3. Again, like crazy, oh my God, like enormous brain. He works for the New York Times now, and he does a lot of really fascinating visualizations, and he did like a whole slew of them in the run-up to the most recent elections. This particular one, the URL is there at the bottom right. You'll see it later in the slides. You should go check it out because it's something, it's truly a marvel to behold. Like, he looked at all of the different states and their electoral votes and how they've shifted over time. And it was animated. You could have it highlight, like, you know, the toss-up states, or you could just use your mouse and hover over like a specific state, and it would highlight that state's path throughout, like, you know, all of the elections going back to like 1950. And if you clicked on, you know, at the top there, you have like chart by size of lead or by electoral votes. It would actually sort, like it would resort. It would take the same information but animate it and show you how it would look if you looked at it a slightly different way. And he's loaded up like each visual element here with a lot of meaning, both their position and their linkages to the other elements and the color and the size. All these things work together to like produce something that is much higher order than like a simple bar chart. Now, encoding too much information onto a single element it's a delicate balance, right? You don't want to do too much. But that's actually one of the more interesting uses of animation, because sometimes you're going to want to encode, like overload this one visual element with like all these different things, but then how are you going to explain all those different things to your audience? Well, you can leave some of it unexplained and use animation to help guide your users. So you show them with all of the visual properties a given element, but then when they click on something and they interact with it or something like that, then the animation moves and all of a sudden it exposes like, oh, I didn't notice that like the color or like the border or the orientation or whatever added this other layer of meaning. So yeah, and it's hard sometimes when we look at visualizations like this, it's hard sometimes to think like, you know, could we do this without text? And you shouldn't actually be afraid of using text. Like everybody talks about self-describing interfaces as being like the holy grail. And I can point to maybe like 2 or 3 like apps on my phone and my computer and websites and whatever that are really truly like self-describing. Like I didn't need any kind of description, just they showed it to me and I started playing with it, and through playing with it in 30 seconds I knew what it was about and I was able to use it and get things done. That's great. But almost all applications and almost all visualizations don't reach that level. So it's not such a bad idea to use some text tastefully, right? You don't want to like overdo it. But if you're going to be overloading like all these elements with all this information, then a little bit of text is not like the end of the world. Just make sure to keep it concise, keep it focused. And I think that's part of what like modern visualizations are reaching towards. Like, you know, in the beginning everybody wanted to do everything only graphical. And now we're actually getting to the point where it's like more hybrid. We're going to throw together like graphics and text and maybe other animated visuals. And again, the New York Times is doing a lot of work that's really fascinating. Who here saw the avalanche snowfall story? I don't remember. Does anybody remember the title of the story? It totally escapes me right now. No? Okay. Google like New York Times like avalanche crazy story or something like that, something about snowfall. And they mix together like all these different like, you know, little visualizations along with story text and whatever to tell a very compelling story. Now, in the browser, like how do we make all of this animation actually work, right? It's a lot of different content. The output of D3 is SVG. And scalable vector graphics are fantastic because they're just XML underneath. And they actually fit right into the DOM. Like they're part of, you know, you have like your HTML and you have your tree of elements. And bam, all of a sudden you have an SVG element, and inside that it has a tree of elements. But because it's part of the DOM, you can style it with CSS. You don't actually need to like apply all of these properties in JavaScript using D3. You can actually apply classes in D3 to your elements and have CSS style your thing. So if an element is like active or something like that, you don't have to say, okay, now make this element orange. You can say give it class active and leave the styling up to, you know, CSS. So that's a nifty property. And you can still target it with JavaScript. Like you can actually target like individual elements using jQuery, which is pretty awesome and leads to a lot of like cool side effects. D3 also supplies like helpers for loading and working with your data. So if you have data that you need to provide to the browser, chances are you're going to be supplying it to the browser in these 2 formats, right? Either JSON or CSV or TSV tab separated values. These are sort of the lingua franca of like what browsers understand. You can go for more compact, efficient representations, but then you also need to write something to deserialize them on the browser side. D3 actually provides you with hooks to like load this stuff up without actually needing to use jQuery. You just ask it for a file, it'll do like the request and provide you with like a promise, a callback, all of that fun stuff. This is actually your first requirement. Like you have structured information that you've like collected for yourself. Now you have to supply it to the browser. Like how are you going to bake that content into a fashion that's convenient for browsers to load? This is sometimes like a tricky step because sometimes your data is just too big to supply like en masse to the browser, like in one giant thing. You need to think about how to structure it. Sometimes you have to have like stand up a server with an API that your web-based visualization is going to query. And we thought about doing that at first. I love Django, but I was actually planning on using Flask for this particular project because it's relatively simple. Like we have our data in Mongo, and I just need to be able to query it it with like a very simple RESTful API, and then spit back the results as like JSON. And because Mongo's output is practically like JSON, this would be like an easy thing to do. But it turned out that we didn't actually need to do that. We could, because we're working with this limited data set of only like the top 2,000 repositories, in many cases it just made sense to split up our data into like multiple JSON and CSV files and just load up the ones that we need. This has some other benefits, including caching. It makes it very easy for both for you to cache it server side and for browsers to cache it, so that when people navigate around, they still have your data, because you can put like a long expires header on your data, and you're not stuck on like, you know, caching it after it comes back from Mongo, but before you ship it off to the browser. So yeah, that's annoying. And like we said, we were on a budget, both in terms of like money, but more importantly in terms of time. So yeah, time. So thinking about how your browser is going to deal with it. Now, each of these formats actually has some like pros and cons, and it's not quite so clear when you're first working with them that it makes sense to use one or the other, and why. So JSON is great. It's easy to serialize to. It's structured. And one of the nicest side effects is that it preserves data types. So if you're sending like an integer, like numeric values, then on the other side, when it gets deserialized, it comes out as an integer. And even in like loosely typed languages like JavaScript, when you're deserializing, sometimes you have like stuff in D3 that expects some integers. And if you don't want to have to be constantly like looping over like any input that you get from your content and turning it into integers, JSON is fantastic because you know you're just going to get it in the format that you sent it. But it has a significant downside in that it's bloated for anything tabular, particularly long tabular data, because it's like JSON, it's like a dict in Python, right? Like you have like keys and values, and you repeat the key over and over again for every key. For every key value pair. So if you have many, many rows, then you're repeating like your metadata over and over again, to the point where literally I took the same data and I output it as JSON and a CSV, and the CSV was maybe like a third the size, and it's a tax that gets worse the longer your data is. So yeah, so JSON has some upsides and some downsides. CSV is mostly easy to serialize to, and I say mostly easy because in Python 2, it doesn't exactly entirely properly support Unicode, and even the docs say like exactly something to that extent, like, hi, we're kind of failsome about this, like see Python 3. But it is structured, and it comes out the other side like a dict. Like when you load it using D3, it still looks like a dict, but everything comes back to you as a string. And so there you do have to do like this sort of looping and converting into whatever formats. And don't even get me started on dates. Dates are like, there's no like, you basically have to serialize into a string and then deserialize from a string. So that's kind of annoying when you're working with dates. So what we actually came up with is a solution that's kind of like a hybrid, I guess, where we put most of our data in a CSV with a header row, so that we have all the benefits of being able to address any one of the fields, not by like their number, but by their name. But then we actually had a separate file that was a JSON file that was like a mapping that said like, this field is this type, and here's some other metadata that's going to be useful for you to represent it. So for example, for numeric things, for every numeric field, it's handy to have around the extents. Like what's the minimum and maximum value that we have for this field. Because when you're going to be showing it on a scale, you need to provide that scale with like, here's the minimum and the maximum, so like, the minimum value should be all the way to the left and the maximum value should be all the way to the right. So we could compute this dynamically in the browser, but that would just slow things down, and you want things to be like peppy and responsive when people load up. Like it's already bad enough that I'm shipping 300K of data like down the wire to them. I don't want the browser to like sit around now and like iterate over every one and like intify every one of those fields, and that's slow. So, and then compare like which one, like sort them and figure out which is the min, the max. So it's like slow enough. So we actually pre-calculated that because it's easy, and we included it in this mapping file, this like sidecar JSON file. So that was like a pretty useful technique, and I highly recommend it for like if you're shipping large data, ship like just the data in one file, and ship everything that describes the data in a separate file. And that also makes it useful in the case where you have like multiple large chunks of data that come in the same format. You can ship like the description file once, and then every time they load maybe like slices of like the large data, they don't need to like reload the description file, they already have it. And yeah, so we had the strings, we have some ints, and we have some dates, and we like parse them according to this, this JSON file that described it. And it's simple, and this file was obviously tiny, so it doesn't really matter. And yeah, in the context of the web, like the 3 rules of like good performance is like caching, caching, and more caching. So one of the other things that we did, because we're not doing an API, is we spit out these JSON files as just static files in like a directory structure, and then makes it easy to query for them. So if somebody needs some information about a given repository from a given user in a given language, we just set it up as like these CSV or JSON files on disk in a directory structure of like language/user/repository name.json. And then when people want to make a query, it's very easy. We just substitute like, the appropriate values, and there's a string, and here, go load that file. So like I said, ghetto, but it works, and it's eminently cacheable. Right. So like, what do we like actually want to show all of you guys, right? We don't actually know. In the beginning, when we first looked at this, we knew even less, and now we know a little bit. And it's frustrating to work with data in this sort of exploratory mode, because you don't know what stories you're going to tell until you start building stories, and that requires a ton of effort. So you build these stories, and then you start seeing some patterns in the data, and you'd be like, oh, it would be really interesting to go back and then like redo this in a slightly different way to expose this aspect that's not like clearly expressed in this. And in a lot of ways, I think that there's a lot of parallels to like good writing. Who here like writes a lot? A little? Okay. Writing is hard. It's like an acquired like thing. You have to do it a lot to get good at it. And data viz, I feel a lot the same way about like working with data viz as I do when I'm trying to write well. Like I need to sit down and I need to think clearly about what I want to communicate. And then I write a lot, and then I throw half of what I wrote away. And data viz in like exploration mode is a lot like that. You build some things and it requires a ton of effort, and then like it really hurts you because you're going to throw some of it away, and you know you're going to throw some of it away. But there's just no way to like get out of that. So yeah. So our data set is like these top 2,000 repositories and all of their associated contributors and all of their associated authors. We needed to come up with sort of like a framework for talking about these. Like, what are the like rough categories of questions that we want to ask? And in the end, we broke it down into these 3 categories. We wanted to look at like people. Like, what can we say about people on GitHub and how people interact and what people care about and what people are spending their time on. Languages, which is sort of everybody's favorite like flame war thing, like oh, Python developers are like this and Ruby developers are like that. Everybody loves their stereotypes. And repositories, which is the stuff that GitHub has already started exposing in terms of data viz, but we think that with like more data, there's a lot more interesting things that we can say, like about the health of the repository, and like has like, for repositories that haven't yet, that started before before GitHub was around or before they moved to GitHub, like since they moved to GitHub, like how has that affected them? What other things can we say about like the history of a repository and the health of it? So these are sort of the 3 languages that, 3 categories that we wanted to talk about. So I'm going to show you now like the actual website that we started building for this. And once again, I'm going to apologize for it being Okay then. I'm going to apologize for it being like will this actually work if I let it be? Oh, I think it'll be too narrow. So you're going to have to see it like in like partial screen mode, because this actually doesn't work if you make your browser too small. Because I had so much stuff and I said, you know what, this is just not going to work for mobile. You're going to have to see it like on a desktop browser, except most desktop browsers are larger than 1024 by 768. So you'll forgive you'll forgive the thing. So yeah, so we started building a project, and like we said, we were going to talk about like these 3 categories, people, languages, and repositories. And what we wanted to focus on when it came to people is the polyglots. Like when we're looking at these top 2,000 repositories, what we're actually looking at is like the cream of GitHub, right? These are the people that are like the most interesting, productive, prolific people. And it turns out that there's a significant amount of crossover between like different repositories in the top 2,000. Like the same people who contribute to the top 200 repositories in language A often contribute to like the top 200 repositories in languages B, C, and D. And so when we talk about trying to narrow in and focus on a story, because you can't tell all stories at once, we thought that this would be like an interesting place to start looking. One of the classic visualizations for networks, whenever anybody talks about network visualizations, is a core diagram. This is also affectionately known as like the hairball diagram, because they all end up looking like hairballs. These core diagrams are basically going to represent, we wanted to represent how these different polyglots contribute to repositories across languages. So initially here, what we have is a core diagram. So for example, here's all the shell developers, and here's their contributions to other languages. And the connections are colored by the more frequent origins. So for example, there's not that much interaction between shell and other languages. Like, you know, C and JavaScript and Ruby are the largest, and there's even less with Python and that. But more people who, like, you know, contribute more to shell contributed to Python than the other way around. Whereas when we look at a language like Ruby, we can see that it's actually kind of all over the map. People who contribute to Ruby repositories are often not the greater contributors to other languages. And these large humps that we see here, they're actually internal contributions. Like, it makes perfect sense that most Ruby developers will contribute more to other Ruby projects in the top 200 than they will to any other language. But the problem with this is that it kind of obscures like this more interesting connections that we have going on between languages. So the next step that we did is we actually factored out all of these like self-contributions. Like, I don't want to see all of the contributions that Ruby developers made to other Ruby repositories. Show me only the stuff. And now all of a sudden it becomes a lot clearer. We can see, like, you know, what different developers are really contributing to across languages. And it's worth pointing out that of the 43,000 like total GitHub users who contributed to these top 2,000 repositories, only about 7,000 have actually contributed to more than one repository. These are like the true polyglots. So what we're looking at here is actually the activity of those 7,000. So here still, when we look at languages like Ruby and C, we see that like there are these rainbow-colored connections between them and the other languages. It means that there's no like unified direction. People from like that language contribute more and that language contribute more. But when you look at languages like C++, it turns out that like C++ developers contribute more to everything else than they get back. Which stands to reason because absolutely nobody likes managing memory, right? And definitely nobody likes managing types in C++. And you can say the same to a certain degree about Perl, and very much so about Shell. But the other languages, you can see that they're that. Another thing is, even when you have text, and this is again like a nice side effect of D3 and making this interactive in the browser, is that you can make your content dance for you. You know, if I want this to be a link that will affect my visualization, then I can make it that way. It doesn't have to be static. It doesn't have to be just animated. But this is purely at the level of the repository. When we actually break it down further into like a more granular like display, looking at like number of commits, then the picture actually changes. Here all of a sudden, like when we look not just by like how many repositories people straddle, but like what's the total number of commits that people have made like to different repositories, all of a sudden C++ developers do receive like love. They receive actually a lot of love. It tells a very different story. And so it's important when you're looking at your data to also think about like these different like angles. It turns out that it can change the story entirely. And when we look at it by commits, the Ruby story changes entirely too. All of a sudden, Ruby developers are showing a whole lot more love to other projects. And shell developers are also showing like a whole lot more love to other projects. Python, we're still sort of like, you know, the everyman in the middle. Like we take, we give, we're like friendly, where everybody's like, you know, nice next door neighbor. But the last like sort of like people connection that we wanted to look at is in the opposite direction. It's coarser. Instead of looking at it like by commits, we wanted to look at it by people. And here, the origin, the links between these languages are not actually colored because they're symmetric. Like for any given pair of languages, if I've contributed to like a Python repository and a JavaScript one, then I count once for either side in this model. So all of a sudden it's symmetric. Now here, what we can actually see, and this is why we added tick marks to this, is like the number of like contributed to repositories or contributors to repositories of this thing. So we can see, you know, Ruby here enjoys probably, like not probably, the largest number of Polyglot contributors. Of them, it's like 4.5, almost like 4 3/4 thousand contributions to Ruby repositories from these Polyglot developers. So most of the 7,000 Polyglot developers apparently, like, you know, like 6 out of 7 or 5 out of 7 like prefer Ruby, which is really interesting. And you can see there are also like these links, these affinities. This is the one that exposes like the most personal affinities. Like JavaScript and Ruby has a lot going on. With Python, we're all over the map. Like we contribute a little bit like here and there and so on and so forth. I was surprised not to see like a tighter link between C and C++. It turns out that there's not like as much crossover between these two languages. Or I thought that maybe it would be like asymmetric. And when you actually look back, here, like, you know, technically all C is C++, right? Is that correct? C++ is a superset of C. So it makes sense that C++ developers like would know how to write like awesome C and would do it more often. Or not, sorry, no, I have that backwards. It should be, or I expected to find, that C developers would contribute more to C++ because anything they write in C is technically valid C++. But it isn't, it turns out that it isn't, or at least that's not expressed in like their behavior. So yeah, so there's a lot of interesting stuff we could show about users. And there's more that we could show if we had more information. The problem with mapping like Git like repo authors to GitHub users, there's like an API call for like turning an email into like a GitHub user. That's actually deprecated. Why is that?
I'll get back to you on that.
Yeah, I'll get back to you on that. We'll circle back. Who read that post? Yeah, but if we could look at a larger, like I'm sure that even this story, it's just a subset of like the full story of GitHub. Like if we could look at a larger sample size, a larger population of GitHub users, like this would change entirely. But I think it would probably have less meaning when you look at the general population. It would slowly devolve into noise because everybody contributes to everything to some amount. It's more interesting to look at like a more like a tighter like lens thing. So chapter 2, and this is not done yet, unfortunately. We really were like sprinting hard to like get this up in time to like release this for PyCon. So you guys are getting a sneak preview, even though it doesn't show you all the information that we have. We have all these metrics for all these different repositories, and we wanted to show like an interesting way of presenting like the top 200 side by side for every language. And how do we do that? But it's not actually interesting to compare like repository like 153 to 153 because that's usually meaningless. What we wanted is to provide like a way for you to sort of like hover over and like compare specific things, and what you should be seeing here if it was working is like, you know, actual numbers for these things. But you can actually go here and see like all these different metrics and compare them. And again, choosing the right scale here is hard because in many cases we have issues where we have like these outliers that stick up and totally ruin the scale for the rest of everything. So yeah, so anyway, we'll be adding that and we'll be publishing this, and then you'll also be able to see what these outliers are, not just in like the JavaScript console. And we still haven't even added like the third thing about repositories, but we're working on that, and we'd love to hear from you if you have like neat ideas. All of this is on GitHub. We'll be releasing our data sets. There's the snapshot that Dana talked about earlier, which is all of the cloned repositories, but there's also like a dump of Mongo that we'll put on there that everybody can get access to as like a big JSON file, and you can like dig into the data yourselves. So come up and talk to us, and we hope that you find this interesting and you'll help us find more interesting stories to tell. Thank you very much for your time.
Thank you, Idan. Now we do have about 5 minutes for questions, if anybody wants to stick around and ask some.
Hi, I got a question here. You mentioned D3, and I didn't catch it. You're using D3 for this visualization?
Oh, yeah. I don't think that this kind of stuff is like, it's either D3 or it's Flash, and you can bet I'm not using Flash.
Okay. My question was, you haven't found any good HTML5 Canvas graphing engines?
So Canvas is a lot like processing in the sense that like you have a canvas and you can draw to it. But like the nice part about D3 is that you marry like your data to the DOM. They actually call it a join, and it's actually like an apt term. Like you join your data to the DOM, and then like when your data changes, your DOM changes. So for example, for all these things, these are just like rectangles that are joined to like a thing, and when I change this metric, what happens behind the scenes is that I've told D3 like, listen, your join, like the join is changed, here's like your updated data, and it actually, like I didn't write new code for like changing the height, it's D3 like changed the height according to the data that I had. And you don't get that for free with processing. You could write that, but you know, then you'd have to write that. So yeah, Canvas is great for a lot of things, like, but not so much this.
Okay.
Yeah, you were talking about when you're receiving your data, the CSV was a lot more efficient for you because it was a lot smaller. Were you using with the JSON an individual object per row in the CSV? Because if you use like individual arrays with the keys just as each one, so it would be kind of the CSV format, but with the arrays as your data.
So you can do that. That also works. But it still ends up being, because you have like all of like the quotation marks about things, you still like there's still a tax that you pay there.
Right.
And like if your file is like 300K long, then like those quotation marks add up.
Okay.
Whereas with CSV, like you're paying a tax of like 1 comma per like per field, or it's actually fields minus 1.
Right.
And that turns out to be like a little more efficient, but that's not a bad approach. It just depends on your.
Okay, I hadn't thought about the quotes being additional text in the JSON.
You talked about this being an iterative approach, and so I wonder if you had any quick and dirty tools to start visualizing things, like not going all the way to D3, and if you use that, what characteristics you would like to have in those back in D3?
Like before you get to, so D3 really is a lot of effort, like both because you spend half of your time like figuring out why D3 is not showing you what you're asking it to show you. And you're like, screw this, I hate JavaScript, I'm going back to Python. But actually, like the best visualization tool is probably IPython Notebook, and just writing like something ghetto that's going to output like a number of like stars or something. Because usually when you're doing like a little bit of visualization, like you put out some numbers, even if you show like you're rendering out to like an array of numbers, sometimes that's good enough for you to be able to like eyeball down the list and be like, okay, this is starting to make sense, there's something interesting here, or all these numbers are roughly the same, there's nothing interesting there. But it's tricky, and like many things, like good writing, like as you like do it more, you get better at like having intuition of like where a good story might be. But it's a problem, like this iterative approach, it starts out very much on like the code side because it's so expensive to do this. And I'm hoping that as we get like better and D3 gets better, like that we get better at the craft of visualizing data, that there will be better tools for doing like this fast. But we're not there yet. It's still in its infancy. So,
thanks.
That's time. I had an answer for you.
Quick question, really quick question. Did you gzip your JSON? because it gets really small when you gzip it.
Yes, it does get really small when you gzip your JSON. I didn't do that because I put it on an S3 and I had to figure out how to do the headers for that, and I didn't have time to do that. But yes, you should totally gzip all of your content.
I have an answer for you.
He's from GitHub, so he should answer. Yes.
It was privacy concerns. That's why it was deprecated.
Privacy concerns?
Because you don't, you can't tell from a flat email if it's a public or private repository. It links to that. So.
Come on, guys, can't you figure that out?
I said I'd get back to you, right?
Okay.
Yeah.
Good job. You're doing good work. Thanks, guys.
Thank you.